Welcome back. This is Mrs. Rubright from Geometry Honors, and our homework review is 11.2, page 722 to 723, numbers 18, 21, 24, 30, 33, and 36. I just started recording this, and I got cut off, so I already do have some of the work on here. Sorry about that, but I'm going to go back through what I was doing before I got cut off. All right, so we are looking for the area of the shaded region. The area of the shaded region is the area of the trapezoid minus the area of the semicircle, okay? So the area of a trapezoid is 1/2 the height times the sum of the bases. 1/2 of 8 times 16 plus 20. So 16 plus 20 is going to give you 36 times 8 divided by 2, and that is going to give you 144. Okay? And then the area of half of a circle. So the area of half of a circle, we have a radius of 4. 4 squared times pi equals, divided by 2 equals, that's 25.13. Okay? So we have the area of the circle, 144, minus, the area of the trapezoid, 144, minus the area of the half of a circle, that's missing. And we get the shaded region as 118.8672. And they wanted us to round this to the hundredths place. So 118.87 inches squared. Okay, that is our first one. The next problem that was requested, find the circumference of circle M. The area of circle M is 260.67. Okay, so if the area of a circle is pi r squared equals 260.67. Divide by pi, and then we're going to take the square root, right? Square root, and that'll give us our r. So 260.67 equals, divide by pi equals square root, and I get that our radius is approximately 9.11. Okay? I'm going to leave this number in my calculator. So what is the circumference? Well, circumference of a circle is 2 pi r. So 2 times pi times the radius that I have stored in my calculator. All right, so that radius times pi times 2 equals, and I get 57.23. And this is in inches. 57.23 inches for number 21. Okay. Number 24 is asking for the length of arc KL. What do we know? We know that the area of the whole circle is 260.67 and the area of the sector is 42. So the area of the sector is to the area of the whole circle as the length of the sector is to the length of the whole circle, or the circumference of the whole circle, 2 pi r. So we need to know our radius first to be able to do this. Well, we just found the radius right above as 9.11. So we're going to just plug that in here. Okay, so cross products and solve. We're going to do 42 times 9.11 times 2 times pi equals 260.67x. Divide by 260.67 on both sides, and we should get our answer. So I already had my radius still stored in my calculator, stored in storage button 1. I put still 1 when I had solved for that. So that times 42 times 2 times pi equals, divide by 260.67 equals, and I got that the arc length is 9.22. And this was in inches. Okay. Number 30. Find the area of the shaded region. All right, so it looks like these are 2 feet, 2 feet, 2 feet, 2 feet. So basically I need the whole circle minus this white circle would give me just this shaded in ring. So the large circle would be 2, 4, 6, 8, right? So the radius would be 8. So the area of a circle is pi r squared, 8 squared pi, right? Minus, we need to take away 2, 4, 6 of them, 6 squared pi. 64 pi minus 36 pi is 28 pi. Okay, so that's going to give you just this shaded region. Now to get this shaded region, I have 4 pi 4 squared pi, right? 2, 4, 4 squared pi, minus 2 squared pi. 16 pi minus 4 pi is going to give me 12 pi. So I have 28 pi plus 12 pi are my shaded regions. 28 plus 12 is going to give me 40 pi. And 40 times pi is approximately 125.66. And this one was in feet squared because it's area. 125.66 feet squared for number 30. Number 33. Look back at the perimeters. Oh, I'm sorry. There we go. Look back at the perimeters of similar polygons theorem and the area of similar polygons theorem. How would you rewrite these theorems to apply to circles? Explain. All right, well, for any two circles, the ratio of their circumferences is equal to the ratio of their radii. For any two circles, if the length of their radii is the ratio of A to B, then the ratio of their areas is A squared to B squared. All circles are similar, so you do not need to include similarity in the hypothesis. And then our very last requested problem is number 36. This one is a challenge question. I'll show you it. Looks like this. It says in the diagram at the right, the arc of FG and the arc of EH are arcs of concentric circles. EF and GH lie on the radii of the larger circle. Find the area of the shaded region. Okay, so I'm going to just extend this picture out like a slice of pizza. So I need to know the area of this slice minus the area of this slice. So in order to do this, let's think about this. So the area of a sector of a circle. So we have pi r squared, but like a portion of it, right? And if we were to do this one, what is our radius of the whole thing? Well, this is 8 and this is x. So, did they give us the angle or anything? I don't think they gave us much information. Okay. And then we would have to subtract the area of this one. And this would be times the portion, right? So times however many degrees out of the 360. All right, so let's think about this arc length. So the circumference of a whole circle with, say, x, right? Circumference is 2 pi r. So 2 pi times x, right, times this, equals your whole circumference. And this one has 10. Times whatever the portion is. We could do this. 10 is to 30 as what is to what plus 8? 30x equals 10 times x plus 8. 10x plus 80 is 30x. Minus 10x, 20x equals 80. Divide by 20. X equals 4. So now that we know that, we know that this whole radius is 12. So 12 squared is 144. 144 pi, a portion of that, minus 16 pi, a portion of that. And it's going to be the same portion on both. So if we were dealing with their whole entire circles, it'd be 402. Let's now think about the whole circle. So the circumference is 2 pi r. 2 times pi times my radius. So my radius is 12. So the full circumference of this whole circle right here would be 24 pi. 24 times pi. And I have 30 of that. So I have 0.39 or 39.8% of it. So if I take this times 0.39788, let's see, times 144 minus 16 times pi times 0.39788, and I get my answer. So when I did that, I got 159.997, which rounds to 160, which is our answer. 160 meters squared. You just have to really think, and you don't always know exactly where you're going when you start. You kind of just think, what do I know? What can I figure out? And you kind of just keep messing with it until you get to the answer. Challenge questions like these are never going to be on a quiz, a test, or an EOC. They won't even be on an SAT or ACT. They really just want to get your mind thinking and problem solving, just starting with what do I know, what can I know, and it's really just a mental workout. Don't get all upset if you struggle with these challenge problems, because they are just that. They are a challenge problem. They're just to get you to think outside the box and to use critical thinking and problem solving skills. I hope you guys enjoyed this review. Please like and subscribe and have a fabulous day.